So the history behind the t-test is that it was developed by William Seeley Gossett, and he was working as a statistician for the Guinness Brewery in Dublin. And because the brewers were really afraid that other brewers would copy patents and things like that, the researchers that would work for breweries were not allowed to publish findings in their own names. So apparently he published it as a pen name called Student. So that's why sometimes you will also hear Student's Tea. So what's the basic idea behind the t-test? The basic idea is to look at two means, the means of group 1 here red and means of group 2 here in blue, and figure out, is this difference here statistically significant or not? And then you can see here two other groups, a red group and a blue group, and you can see the same distance, right? The same distance, but we could see that these two distributions are much less different from each other than these two, right? You get a little bit of overlap between these two here, and we have a lot of overlap between these two. So essentially what the t-test does, it measures the difference between the groups, and it measures the distribution of each group and compares these to each other. All right. So let's imagine that you have a distribution with low variability. That distance here seems like a big difference between these two groups. If you look at two groups with high variability, that difference in mean doesn't seem to be that meaningful because the groups really overlap to a large extent. So in order to calculate a t-test, we take the difference in the means, we look at the sample size, and we look at the variability of the data, and based on that we calculate a t-value. And then we compare that t-value with the appropriate t-distribution, and we see, well, what's the chances of obtaining such a t-value if the null hypothesis was true and really there was no difference between the groups. Right? Normally we expect a t-value of around 0 if there's really no difference. But then if we get larger t-values after a while, if they become too large, or we say, you know what, that's really unlikely that we get a value that's way out here, then we would start rejecting the null hypothesis, because the evidence that we gather from our data suggests that our null hypothesis is very unlikely